Hey guys, in this video we're going to be starting 7A.2. Our master learning objective is I can solve real-world problems by creating a diagram and applying the Pythagorean theorem. So we're still using that theorem from before. We're just kind of using these real-life scenarios to kind of help us out to figure out a missing side or a missing hypotenuse, depending on whatever scenario we have. So looking at this first example, it says a painter leans a 15-foot ladder against a house. The base of the ladder is 5 feet from the house. To the nearest tenth of a foot, how high on the house does the ladder reach? So again, what we're trying to think of is we're going to have a triangle, right? We're going to have, it looks like it says we have a ladder against the house. So 15-foot ladder against the house. That means my ladder is diagonal, right? Kind of think about it, right? You lean your ladder. You don't have to draw a picture. It's just going to be a triangle, kind of wanting it to make a little bit more sense. And that's going to be 15, right? The base of the ladder is 5. So anytime you see that word base, base means bottom. Bottom equals base. So therefore, the bottom is 5. To the nearest tenth of a foot, how high is the house, right? How high is talking about your distance going upward. So that means this is what I'm looking for. My height of how high that ladder is on my house, okay? So now when we label this, that means that this, this is my right angle. Therefore, across from that, this is my hypotenuse, which is my C. And then these are my two legs, right? We can say that this is equal to B and that this is equal to A. So when we set up our equation here, A squared plus B squared equals C squared. We're going to go ahead and substitute that in. A was X, so X squared, plus B squared, which was 5 squared. And C was 15, so therefore this is going to be 15 squared. We want to solve for X, so we're going to bring our X squared down. 5 squared is 25. And 15 squared is 225. So again, if you need your calculators, please go ahead and grab those. You can always check as I'm moving along. When we are solving for x squared, we have to do the opposite operation. So therefore, we are going to subtract 25 on both sides. So x squared is going to equal 200. I want to solve and get my x by itself. I do the opposite in operation, which is taking the square root of both sides. And x is going to equal about 14.1 feet. So that is how high my house is to the nearest 10th power. All right, scrolling this on over. Looking at example number 2, it says we have a baseball diamond that forms a square. So let me go ahead and draw my picture here. So a baseball diamond typically kind of looks like something like this, right? All these plates, and what's nice about a diamond is that all corners are 90 degrees. It forms a square, right? So that was my square. If it is 90 feet from home to first base, so remember this is home base, to third base, this is first, this is second, and this is third base. So it tells us that it's 90 feet 90 feet from home to first base. So that would be home to first base. This is 90. And since they also told us that this is a square, You remember that square has the same length on all sides. So that's 90. This is also 90. And this is also 90. And this is also 90. Right? It's a square. Then what it's asking us is, how far does the catcher at home have to throw to reach second base? So what I'm looking for is, I'm at home, I have to throw the ball to third base. I'm trying to figure out what that distance is. So really, this, I have first, then to second. So this on this side, we can kind of ignore this. I don't want to say it's not important, but for right now, it's not important. Right? We don't really care about what's going on that side. We are just going to be looking at this right triangle right here. So when we set this up, if this is my 90-degree angle, that's going to make this my hypotenuse, which is my C. And this would be my A, and this would be my B. Right? So I'm going to go ahead and set up my equation. Right? A squared plus B squared, right? Same formula, equals C squared. One of my legs was 90 degrees, so 90 squared. My B was 90 also, so 90 squared. And I'm trying to figure out my hypotenuse, which I labeled as x. So that's going to be x squared. Simplifying this, 90 squared is 8,100 plus 8,100 equals x squared. When we add these two together, I get 16,200 equals x squared. I want to take the square root of both sides, and when I do that, x is going to equal about 127.3 feet. Nice. Kind of also another reason why you never really see someone try to steal third or first base, because they would only have to run 90 feet, right? If you're at catcher and you have to throw it to first base or to third base, you're only throwing the ball 90. In this case, right? Versus someone who's at first base and wants to steal second base, that catcher has to throw it a lot further, which is why you see a lot of people try to steal second, and why it's kind of hard to steal third base. For all of you baseball fans, fun fact. All right, looking at example number 3, we have the distance between 3 cities on a map are 45 miles, 56 miles, and 72 miles. Do the positions. Why is that going through? My board is haunted. So for some reason my board is not letting me scroll down, so I am going to have to draw this a little bit on the smaller end, but hopefully you'll still be able to see it down here at the bottom. So actually I'm going to use the top and the bottom. So I'm going to use this space here. So it says the distance between 3 cities on the map are 45 miles, 56 miles, and 72 miles. So we have 3 destinations, right? And what we're doing here is we're just going to have to draw 3 points, right? 3 cities, so we draw 3 points on a map. So literally make it however you want to look. From here to here to here, right? Between one city is 45 miles. So from between here to here, we're going to say this is 45. And then from the next city, this is 56. And then from the next city, this is 72. Oh, I never even labeled the 56. Now, what you're thinking is, well, how do you know which one is the right angle? The way that you know which one is the hypotenuse is whichever value of the side is the biggest side. So when we finish reading this, it says, do the position of the 3 cities form a right triangle. how do we determine this? So we're going to assume that it does create a right triangle, which would mean that the biggest value, which is 72, is our hypotenuse. The longest side is always the hypotenuse. I do apologize for my board not scrolling down, and I'm writing really small, but for some reason it's won't let me scroll. So let's assume that is our right angle, which means this would have to be A and that would be B, right? Or vice versa, it doesn't really matter. So when we go ahead and substitute this in, we're going to say that our A squared is 45 plus 56 squared equaling 72 squared. So again, it's asking us if it is a right triangle. We're assuming it is, and if it is, then the left side should equal the right side, right? Because I'm not missing any variables here. So we're just going to simplify individually. So 45 squared is 2,025, and 56 squared is 3,136, and 72 squared is 5,184. So if this is a right triangle, when we add the left side at 2,025 and 1,336, it should equal 5,184. However, when we add it, let's see if I can scroll now. When we add it, oh, now it's letting me scroll. We would get 5,161, which in fact is not equal to 5,184. So is it a right triangle? No, it's not, because this would not work. It does not equal. So therefore, we just say no, not a right triangle. And how do we determine this? Well, you assumed that our longest side was our hypotenuse. We set up equal our equation, and it did not simplify. Example number 4. It says a jogger runs 8 miles north and then 15 miles west from a straight point. What is the shortest distance she must travel to return to the starting point? Round your answer to the nearest tenth. So looking at this, it says we are going to run 8 miles north. So we're at some point and we're going to run north, which is upwards, and this is 8, right? And then from there, it tells us that we are going to run 15 miles west. So 15 miles west is going to be going this direction, to the left. And now it's asking us, what is the shortest distance you can travel? So shortest distance is always a straight line. So that would be from here back to her starting point. And this is what we're trying to find, right? This is my 90-degree angle. Therefore, it gives me across from that is my hypotenuse, which is my C. And then A and B, again, does not really matter. You can make the 15 A or B. You can make the 8, whatever other one you did not use. So that does not matter because they're going to be on the same side anyway. So setting this up, A squared plus B squared equals C squared is going to be 15 for A, 8 for B, and C, we don't know what C is. Oh, we can write X squared. So 15 squared is 225. 8 squared is 64. And we still don't know what that hypotenuse is. We add 225 and 64 to give us 289. We take the square root of both sides. So therefore, 17 is our hypotenuse, and that is the shortest distance that she would have to travel after running 8 miles north and 15 miles west. Looking at the next, or the last 2 examples here, looks like we have a ladder again. Example number 5, it says the foot of a ladder is placed 6 feet from the wall. If the top of the ladder rests 8 feet up on the wall, how long is the ladder? So looking at this, the ladder is placed 6 feet from the wall. So therefore, that would be the distance from the wall to the base of the ladder. So this is 6 feet. And then if the top of the ladder rests 9 feet on the wall, that is how high the ladder is resting on the wall, right? So this would be 8 feet. What we're looking for is how long the ladder is. So the ladder, again, is that diagonal point, right? It's what you're actually resting on the wall. So this is what we're trying to find, which would be my C, because this is my 90-degree angle, right? That's my hypotenuse. And then our 8 and our 9, our 8 and our 6 would be our A value and our B value. So setting this up, A squared plus B squared equals C squared. 6 squared plus 8 squared equals C squared. 6 squared is 36. 8 squared is 64. And C squared is still C squared. Adding 36 and 64 is 100, equal to C squared. Take the square root of both sides. So C is 10. So therefore, our ladder would be 10 feet, right? So make sure we have our units in there if it's asking us. Example number 6, a park is in the shape of a rectangle, 8 miles long and 6 miles wide. So when we have my rectangle here, it's going to be 8 miles long, 6 miles wide. So if this is 8, that would make this 8. If this is 6, that would make this 6. And what's nice about a rectangle is that all angles are 90 degrees. Then it says, how much shorter is your walk if you walk diagonally across instead of along the two sides? So what we're looking then is if we walk across here, right? This would be our C. So really you only have to pay attention to one triangle. So if you want to, ignore the top half again, right? We're not looking at this triangle. We're only going to be looking at the bottom one, which would give us the fact that our A and our B would then be 8 and would be 6. So actually, looking at our equation here, we're looking at A squared plus B squared equals C squared. A squared is 8, so 8 squared plus 6 squared equals C squared. This is actually kind of the same problem as the one right next to it. So 8 squared is 64. 6 squared, what's the plus sign? Plus 36 equals C squared. 100 equals C squared. Take the square root like we just did, and that's going to give us 10 miles is equal to C. But the question says, how much shorter is your walk if you walk diagonally across than along the two sides? So diagonally, we walk 10 miles. And then the sides, what do we walk? If we have to walk both sides, we have to walk 6 miles. And then we have to walk 8 miles, which is 14 miles. So how much shorter? Well, subtract 14 and 10. Therefore, the diagonal is 4 miles shorter. So I would walk on the diagonal, and that would be my answer. All right, go ahead and work on 7A.2, and then there is a little mini quiz. Good luck.